Okay guys, so we accomplished a discussion over the 18th question from matrices, and there are few bunch of concepts left to be discussed over matrices which are going to be clear with the further questions that we are going to do in this session. So let's see the next question from matrices itself. It says A is this 2 cross 2 matrix, 0 minus tan alpha by 2, tan alpha by 2 and 0, and I is the identity matrix of order 2. Then show that I plus A is equal to I minus A multiplied by this square matrix of order 2 cross 2. Of course, if I is a matrix of order 2 cross 2, A is a matrix of order 2 cross 2, I minus A is also a matrix of order 2 cross 2. This matrix that you can see is of order 2 cross 2. So first of all, they are conformable for multiplication, and this complete final matrix is also of order 2 cross 2. And here I and A both are matrices of order 2 cross 2, so their sum is also a matrix of order 2 cross 2. So let's justify the question and try to absorb that the statement is completely valid. Matrix of order 2 cross 2 is being asked to prove to be equal to another matrix of order 2 cross 2, which makes sense. Okay, if suppose this would have been a matrix of order say 3 cross 3 and this would have been a matrix of order 2 cross 2, here itself we would have said that these two matrices can never be equal. So, this question is first of all a valid question. How do you prove that? So, you have A as 0 minus tan alpha by 2, tan alpha by 2 and 0. I have to show I plus A, which is which matrix? 1 0 0 1 plus 0 minus tan alpha by 2, tan alpha by 2, 0. I plus A is what? 1 plus 0 is 1, 0 minus tan alpha by 2 is minus tan alpha by 2, 0 plus tan alpha by 2 is tan alpha by 2, and 1 plus 0 is 1. Okay, this is I plus A. Now consider I minus A multiplied by, so I minus A multiplied by cos alpha minus sin alpha, cos alpha. What is I minus A? Let's evaluate over here. I minus A would be 1 0 0 1 minus 0 minus tan alpha by 2, tan alpha by 2 and 0. Now I need to subtract and not add. So two matrices are subtracted, results in a matrix of order 2 cross 2, which is obtained when you subtract the corresponding entries. So 1 minus 0 gives you 1, 0 minus tan alpha by 2 gives you tan alpha by 2, 0 minus tan alpha by 2 gives you minus tan alpha by 2, and 1 minus 0 gives you 1. So your I minus A is 1 tan alpha by 2 minus tan alpha by 2 and again 1 multiplied with cos alpha minus sin alpha, cos alpha. Now here basic matrix multiplication I have to perform. This is a matrix of order 2 cross 2, this is a matrix of order 2 cross 2. So the product of them is valid, they both are conformable for multiplication, and the resultant matrix will again be of order 2 cross 2, which is going to have a 1 1th entry, 1 2th entry, 2 1th entry and 2 2th entry, and we know how they are obtained. So 1 1th entry will be obtained when first row is multiplied with first column. 1 into cos alpha plus tan alpha by 2 into sin alpha. So you get cos alpha plus sin alpha into tan alpha by 2. Then 1 2th entry will be obtained when first row here is multiplied with second column here. So it is minus sin alpha plus cos alpha into tan alpha by 2. Then 1 2th entry is obtained, or 2 1th entry is obtained when second row here gets multiplied with first column. Second row here gets multiplied with first column. So you get minus cos alpha tan alpha by 2 plus sin alpha. Fine, basic, I am just multiplying the matrices, and 2 2th entry when second row here gets multiplied with second column. So you get sin alpha tan alpha by 2, this into this, plus cos alpha. And now it's time to somehow relate alpha with alpha by 2. You all know by what formula can I write sin alpha in terms of alpha by 2 or cos alpha in terms of alpha by 2. Let's recall that. I can write cos alpha as 1 minus 2 sine square alpha by 2 plus sine alpha can be written as 2 sine alpha by 2 cos alpha by 2, and tan alpha by 2 can be written as sine alpha by 2 upon cos alpha by 2. Just see how everything is being converted in terms of alpha by 2 with the help of trigonometric identities. In here I have minus sine alpha, so it is minus 2 sine alpha by 2 cos alpha by 2, right? That's what the identity says. And then you have plus cos alpha into tan alpha by 2. So tan alpha by 2, cos alpha can be written as 2 cos square alpha by 2 minus 1. And this tan alpha by 2 can further be dissolved as sine alpha by 2 upon cos alpha by 2. Let's come to 2/1th entry, minus cos alpha, this is minus of, let me write tan alpha by 2 which is sine alpha by 2 upon cos alpha by 2. Inside there is cos alpha which can be written as 2 cos square alpha by 2 minus 1 plus sine alpha which is 2 sine alpha by 2 cos alpha by 2. Then here it is sine alpha which is again 2 sine alpha by 2 cos alpha by 2. Tan alpha by 2 is sine alpha by 2 upon cos alpha by 2 plus cos alpha which is 1 minus 2 sine square alpha by 2. We have dissolved this complete matrix. Now in here you can clearly see cos alpha by 2 cancels out. This is 2 sine alpha by 2 into sine alpha by 2 which is 2 sine square alpha by 2 with a plus sign and 2 sine square alpha by 2 with a minus sign. This gives you 1 minus 2 sine square alpha by 2 plus 2 sine square alpha by 2. This minus and plus gets cancelled out, you are just left with 1. Here if you come and see cos alpha by 2 over here, not here, this is going to remain as it is. If you multiply it inside, cos alpha by 2 cancels out, you are left with 2 sine alpha by 2 into cos alpha by 2 minus tan alpha by 2. So minus 2 sine alpha by 2 cos alpha by 2 plus 2 sine alpha by 2 cos alpha by 2 minus tan alpha by 2. So you are just going to be left with minus tan alpha by 2. Here if you carefully see, if you multiply this, you are going to get what? Sine alpha by 2 upon cos alpha by 2. This cos alpha by 2 and cos alpha by 2 gets cancelled out. You are left with minus 2 sine alpha by 2 cos alpha by 2 plus tan alpha by 2. And here it is plus 2 sine alpha by 2 cos alpha by 2. So this and this gets cancelled out. You are just left with tan alpha by 2. And here eventually this gets cancelled out. Minus 2 sine square alpha by 2 plus 2 sine square alpha by 2 gets cancelled out plus 1. This is what you are left with. And here if you focus upon I plus A is also the same matrix, and therefore this has come out to be equal to I plus A. Is it clear? So we showed that yes, I plus A for this A was equal to this respective matrix, because not just their orders came out to be same, this is also 2 cross 2 matrix and this is also 2 cross 2 matrix. In fact, component wise entries are also same. Okay? Let's talk about the next question. It says express this matrix B as a sum of symmetric and skew symmetric matrices. Now please understand there is a very basic concept behind expressing a given matrix as the sum of symmetric and skew symmetric matrices. What is that concept? The concept is that give me any matrix, I can write it as sum of symmetric and skew symmetric, P plus Q, where P is symmetric and Q is skew symmetric. What is that P and what is that Q? Half of A plus A transpose is P and half of A minus A transpose is Q. Yes, we have done that in theory. You all would have checked that this matrix is symmetric and this is skew symmetric. And therefore, with the help of A, you can obtain half A plus A transpose and half A minus A transpose, and when you add both of them you get back A, and therefore you are able to express A as the sum of a symmetric and a skew symmetric matrix. When I say symmetric, I mean the transpose of the matrix is same as the matrix itself, and when I say skew symmetric, I mean transpose of the matrix is equal to negative of that matrix or the additive inverse of that matrix. So let's see, here we have A as, or I should say B as, a 3 cross 3 matrix, 2, minus 2, minus 4, minus 1, 3, 4, 1, minus 2, minus 3. Let's first obtain P, which is half of B plus B transpose. Okay, this is half of B plus B transpose. What is B transpose? First row becomes first column, 2, minus 2, minus 4. Second row becomes second column, minus 1, 3, 4. Third row becomes third column, 1, minus 2, minus 3. Add B and B transpose, both have the same order, so component wise addition will take place. 2 plus 2 gives you 4, minus 2 minus 1 gives you minus 3, minus 4 plus 1, right? Then minus 1 minus 2, 3 plus 3 is 6, 4 minus 2 is 2, 1 minus 4 is again minus 3, minus 2 plus 4 is 2, and minus 3 minus 3 is minus 6. Let's just check. 2 plus 2 gives you 4, minus 2 minus 1 is minus 3, minus 4 plus 1 is minus 3, minus 1 minus 2 is minus 3, 3 plus 3 is 6, 4 minus 2 is 2, 1 minus 4 is minus 3, minus 2 plus 4 is 2, and minus 3 minus 3 is minus 6. Scalar times a matrix gives you a matrix wherein each entry is multiplied with that scalar. So 4 by 2 gives you 2, then here it is minus 3 by 2, minus 3 by 2, minus 3 by 2, 6 upon 2 is 3, 2 upon 2 is 1, then again minus 3 by 2, 2 upon 2 is 1, minus 6 by 2 is minus 3. You can also check that P is symmetric. If you try to find out P transpose, first row is replaced with first column, 2, minus 3 by 2, minus 3 by 2, second row becomes second column, third row becomes third column. You can clearly see P transpose and P are exactly the same. Therefore, P is symmetric matrix. Let's now obtain Q. Q is half of B minus B transpose, which is half of what? B minus B transpose. 2 minus 2 gives you 0, minus 2 plus 1, minus 4 minus 1, then you have minus 1 plus 2, then 3 minus 3, then you have 4 plus 2, then you have 1 plus 4, then you have minus 2 minus 4, then you have minus 3 plus 3. Okay? Here if you divide it by 2, you obtain 0, minus 1 by 2, minus 5 by 2, 1 by 2, 0, 3, 5 by 2, minus 3, 0. If this is your Q, you can check that Q is skew symmetric, because when you find out Q transpose, first row becomes first column, second row becomes second column, third row becomes third column. You can clearly see Q transpose is same as negative of Q. Why negative of Q? Because negative of Q is what? Just multiply each entry with minus 1. 0 into minus 1 is 0. Here it becomes this. This is minus half, 0, minus 3, minus 5 by 2, 3, 0. This is minus Q and this is Q transpose. You can clearly see both these matrices are exactly the same. So you have got that Q transpose is same as minus Q. Therefore, Q is skew symmetric. So you have produced a matrix which is symmetric, you have produced a matrix which is skew symmetric. The only thing which is left is to show that B can be written as the sum of these two matrices. So if I add P plus Q, what is P? P is 2, minus 3 by 2, minus 3 by 2, minus 3 by 2, 3, 1, minus 3 by 2, 1, minus 3, plus Q. Let's take up Q into consideration. P has been written. Q is 0 minus half minus 5 by 2. So basically when I did half of this, what did I get? 2 minus 3 by 2 minus 3 by 2. This is it. Yeah. So I got my P, then Q is what? Q is 0. Yeah, so Q is 0. Then there is minus half, minus 5 by 2, 1 by 2, 0, 3, 5 by 2, minus 3, 0. P plus Q you need to do. 2 plus 0 is 2, minus 3 by 2, minus 1 by 2 is minus 4 by 2, which is minus 2. Minus 3 by 2, minus 5 by 2 is minus 8 by 2, which is minus 4. Minus 3 by 2 plus 1 by 2 is, minus 3 plus 1 is minus 2 by 2, which is minus 1. 3 plus 0 is 3, 1 plus 3 is 4. Minus 3 by 2 plus 5 by 2 is 2 by 2, which is 1. 1 minus 3 is minus 2, and minus 3 plus 0 is minus 3. Let's check. 2 minus 2 minus 4. Minus 1, 3, 4. 1 minus 2 minus 3. This is my B. So I have expressed B as the sum of two matrices. P is symmetric, Q is skew symmetric. Clear? Easy enough? Let's talk about the next question. It says that if A and B are symmetric matrices of the same order, then what is the nature of AB minus BA? Is it skew symmetric? Is it symmetric? Is it identity matrix or a null matrix? What is it? Now A is symmetric. If A and B are symmetric matrices, that means what is the quality they possess? This implies A transpose is A and B transpose is B. In order to show that AB minus BA are symmetric or skew symmetric or zero or identity, we have to play with their transpose first of all. Especially both these things are completely related with the transpose behavior of the matrix. So if I consider AB is one matrix, BA is one matrix. So these are actually two matrices being subtracted, thereby resulting in one single matrix. So you know that transpose of difference of two matrices is difference of their individual transpose. So AB minus BA whole transpose is AB transpose minus BA transpose. Here I have just used the property of transpose. Now transpose of the product is product of the transpose of the individual matrices taken in reverse. The reversal law of transpose. So this will be B transpose into A transpose and this will be A transpose into B transpose. But B transpose is same as B, A transpose is same as A transpose is A, B transpose is B. I have got BA minus AB, which is definitely not equal to AB minus BA. I can write this as minus of AB minus BA. Which means if this complete matrix is say P, then you have got P transpose is minus P. And therefore your matrix P, which is AB minus BA, is not symmetric, not identity, not null, but it is skew symmetric. AB minus BA is skew symmetric matrix. And therefore your correct option is option A. Clear? Moving to the next, we have obtain the inverse of this matrix using elementary operations. Now one such question you will definitely see in your paper for a 6 marks, and therefore it is utter important to understand how to obtain the inverse using elementary operations, also how to write each and everything and get full marks. Because many times what happens that students do obtain the correct inverse, but because they skip their steps which are utter important in such questions, they do miss out on certain marks and are not able to obtain 6 on 6 completely. So let's begin. A is given to me, which is a 3 cross 3 matrix, right? In here, if already the question is saying obtain the inverse, you don't need to bother about the determinant being non-zero. The question is not going to give you a matrix whose determinant is 0 and it is asking you to obtain the inverse. So don't waste your time evaluating the determinant of this particular matrix, and then eventually you're going to get a non-zero number, thereby writing that okay, so that is why the square matrix has an inverse, and then going on to compute the inverse. There's no need to waste your time in there. Directly jump on evaluating the inverse. It is a square matrix. Assume its determinant is non-zero. Because it is non-zero, you don't need to prove it or show it, and get ahead with obtaining the inverse. So how do you do that? The basic algorithm, you consider what? A equals IA is what you consider. You know that? Identity matrix of order 3 cross 3